Hi, welcome back to the mini Rust in Rust series, if that's what we're calling it. This is video 17, and as you may remember, we have been working with this guiding test, which is going to help. Eventually, we're going to get there, which is we're going to have a assignment statement that says, look, x is an I32, and then we're going to try and assign it with 3.0, which is not an I32. It's not an integer. It's a floating point. We have one last piece of the puzzle left, which is we can't actually lex this 3.0 and recognize it as a floating point. At the moment, it will just fail in some way, I think. So we just need to do the lexing part, and I think the parsing part is kind of either nothing or very simple. And then we'll be able to actually think about how we're going to make this type checking code actually take a statement like that and use it. So let's see how we go with a bit of lexing. So let's look at our lexing tests, find a sensible place to put this. The last thing we did was this thing, so let's just extend that a little bit. And, oh no, let's make it really simple. So can lex floating point. So we'll just do 3.0. And that means I will probably want to put this up near the thing where I said I could lex an int, right? Lex symbols, lex addition expression, lex multiple tokens, lex a multi-character int. So let's go for lex floating point number. And it's going to lex just as a token called, let's just say float, shall we? And it's going to be like this. And I think it's just going to be similar to an int. It's going to have just the string representation of it and where it is in the thing, and it's going to be 0, 1, 2, so it's going to be 3 long, so that even that is right. Okay, so let's make ourselves that float method. It's going to be very similar to the int method. And it's only used in tests, at least for the moment. And the only difference from int is that the type of it is float, and that means we need to make a variant of token kind called float, which we'll put next to int. And it's not being used, but we're not worried about that yet. So, any errors? No. Okay. So it's never constructed because we haven't actually written a lexer yet. So let's try it out. Right. So complaining because we're currently trying to lex an int, and there shouldn't be a full stop or dot inside an int. So our lexer is naive. At the moment, what it says is when I find a number, then start parsing an int. And actually, this should be an int or a float. We need a method called int or float, which then decides, is this an int or a float? And it's going to look a bit like int, I guess, and then it's going to branch off. So let's rename int to int or float. And if we find a dot, then we, I guess, call self.float, and we pass in what we've already found. I think. And otherwise, if we get to the end of this without having done that, this should be, we should bail out here. We should bail out. If we get to the end without that happening, then it must have been an int. I think that's how this is going to work. So this should be like so far, number so far will be ret, which is a string. I kind of feel like I want to include the the dot in there. So let's modify ret before we return it. Do the same thing as what we did up here, which is kind of satisfying, I guess. Okay, something like that. And what does float do? Well, float does something quite similar. I guess this should be, what should we call this? I mean, this name has to do two jobs. So let's just say, well, so far it's had the string representation of it so far. So far was a kind of reasonable name from the outside, but we're now going to reuse it. So let's just call it chars, right? And we're going to return chars at the end. We're going to return a token made out of chars at the end. Its kind is going to be this new token kind float, and it's going to be built out of chars, and its span is going to be, yeah, same as this. Where len is the length of the thing that we're returning. So we're close already. Let's just see what happens when we run it like that. I think it will say, it should say 3.0, and instead it says 3. And then it found a 0 afterwards, obviously. So we've actually got to pull in the rest of the characters of this thing. So we just do another while loop. This is nice and simple, isn't it? Lexing's good. Isn't Lexing good? So there's no more dots allowed. We're just looking for numbers 0 to 9. And that means this should be mutable. And are we okay with mutating the thing we got passed in? I don't see why not. Otherwise, bail out and complain. And look, we can lex that already. So can we just automatically parse it? I'm not sure. Let's figure it out. So, have we got parsing for just integers on their own? Parsing a number produces a leaf expression, so let's just rename that. To parsing an int produces a leaf expression. And let's just double check. We can also do that. Parsing a float. So let's try 99.999. Now it would be quite nice to allow underscores in numbers, and we from looking at that code we can see it would be pretty straightforward, wouldn't it? And that is 6 long. Okay. Unexpected token 99.999. I guess then the parser does actually need okay, so leaf token is not the same as token kind, right? Okay, yeah. So we need to define a method on leaf token that allows us to make a float, and that means we're gonna, yeah. So we've got this kind of copy. So I'm glad I almost stopped the video there and said, right, we're done. Because I was confident that that we'd finished because there was nothing to do here, but I was totally wrong. We also need our leaf token kind to have a float type. Oh yeah, I remember now. So token kind is one big list of everything, every type of token, whereas a leaf token is a particular type of token that the parser knows about. So I feel like maybe leaf tree would be a better name than leaf token. Let's just drop a to-do there. To-do. Maybe these should be named, e.g. leaf tree kind. Well, and leaf tree. Let's put it in leaf tree, etc. because it's not a token anymore. It's just the leaf of a tree. So maybe leaf would be a good name. Oh no, but then there's other things like symbol. So what's the difference between a leaf tree and a symbol? No, a symbol is a type of leaf tree. Yeah, so there's leaf token and there's symbol. No, there's symbol token and leaf token, which is of type symbol. Okay, I'm not going to think about that now. Maybe this is wrong, or maybe the naming is not helping me figure it out and we can make it better. All right, how am I doing now? I got some compile errors. Missing float. Yeah, so when we're dealing with a leaf in the evaluator, we need to deal with all the different types of leaf, and we're not yet dealing with floats. So I guess for now we can just fail it and deal with it in the future. Oh, maybe we've got time to deal with it in this. So let's do nothing for a second, because we're going to need a test before we do something. But yeah, I guess we want to map it to a value of type float or something, don't we? It might. So what can we do here? It's returning results, so we could return an error. Maybe returning an error would be the simplest thing to do here. Let's return an error of type invalid number. And then just copy what we've got here. I think we need an into to turn this into a miet error. Okay, seems happy. Not using that literal yet. Is our code compiling? No, because parsing is still failing, saying I found a token I wasn't expecting. So let's look at the parser. And what the parser does is just says, find the next thing, which it looks at it for an expression. The only types of expression it currently deals with is a leaf, or is either a keyword or a leaf or unrecognized. Now if we're looking for a leaf token, which is what we got in this case, we go into leaf or operation and we look for token and we say, does this have type operator? No, we've somehow skipped past where I wanted. So when leaf token comes out, why are we not considering this to be a leaf token? I think it must be because the try into is not doing it, is that right? So it's interesting to me that the compiler is not guiding us towards fixing this problem. So let's have a look at leaf token. There must be a try from token for leaf token. Yeah, here's our problem. And we've got a catch-all here saying this wasn't a leaf token, but actually I kind of want to get rid of the catch-all and just list all of them, and then this wouldn't happen again. So how awkward is it to just list all the possible things? Because now look, float gets filled in for us. By the way, you can see that my language server protocol thing is not working properly. Don't know why. All right, let's just do this, and then we might regret it later. If this blows up massively, then oh, you know what? I shouldn't be doing this. I should be doing an or expression, right? So delete all these things because they're all going to get the same thing. And then this goes at the end. And then we put ors in between them. If it's this or this or this or this, this is going to get its own thing. And it's going to look very similar to this. Except it's going to be a float with, whoops, with that F that we found. Yeah, so these, anything that's an operator keyword equals or colon, semicolons, all are just not a leaf token, so we fail. This is kind of making me think there must be an equivalent of these for symbol token or operator token. And I feel like maybe, I don't know, maybe there's only one operator, so it's okay. Maybe that's okay. We'll see. If we find that this is error prone as well because of this catch-all, maybe that should get fixed too. All right, so now all our tests pass. And our ignored test, with any luck, is ignored. Ignore is going to fail because we haven't actually implemented the functionality, not because parsing or something failed. Yeah, so it's now complaining that we couldn't understand this number literal, which is an evaluation time problem. It's that number error that I just put in. So the only part of this that's failing is the evaluation, not the lexing or parsing. So I think we've probably got time to evaluate a float as well, right? Evaluating a float gives the correct. Let's say, I think an F64 is the default float type in Rust. Let's just double check that. If we just make a float, what's its type? It's F64. Okay, as I thought I remembered. So this should give us a value F64 of, let's use it. We always use different numbers, right? 9.76. And there's no such thing as an F64, so let's make one. And we're starting to flesh out the possible values you're allowed to have in our mini Rust. Now we have i32s and F64s. And that's going to cause problems. Because if you're plussing things, then I guess we're going to want to be able to plus F64s to each other. But for now, there's a whole load of other things that we might be plussing, which we don't want to allow you to plus. Because Rust basically doesn't let you plus things that are not the same thing as each other. Hang on, I'm doing this wrong. It should be in here, I think. Where does this match statement end? Oh, it ends there. I was right first time. So anything else, let's just say, this is an error for now. It's going to be, like, you're not allowed to add those things together, right? Not sure what kind of error. I think it might be a new type of error. To say those things can't be added. So what types of error do we already have? We only have invalid number. So let's make a new one. Let's just say cannot add those types. And again, let's get a better error description in future. And let's call it unable to add. I mean, that's not even... invalid types for operator, maybe? Invalid types for operator. I cannot use these types with operator. Maybe something like that. And then we need to have an operator in here. Maybe that will be good. So this is going to be invalid types for operator. And it's going to need... We're going to need to copy some code that does this because I can never remember how you do it. And we're probably going to need an into afterwards, aren't we? We have missed operator. So operator is going to be... Oh, we haven't got it. So we have to do that thing that I did for expression, don't we? We have to say self dot file contents sliced with operator. This still feels wrong. Still feels like we ought to be able to do it better. Operator dot span dot. This is like the beginning of the span. Dot dot the end of the span, which is operator. Dot dot the end, which is operator, which is the span. The beginning of the span plus the other bit plus the length, and then we have to turn this. Once we've sliced it, we have to turn it into a string, which I think is to owned. And now this is not leaf but operator. That looks right. So, still complaining that we don't have a construct in F64, so I guess there's still some stuff missing from our evaluator. But now we've got a test that explicitly tests that, which is we should be able to turn this into an F64, but currently we're getting number literal could not be understood because we added in an invalid number when we shouldn't have, because right here. So what we should be doing is saying F32, no, F64 from maybe? Let's have a think. What does F64 support in terms of converting from a string? So, I guess it's going to implement from, maybe, from str. Okay, it implements from str, converts a string in base 10 to a float. Well, that's what we're expecting. Accepts an optional decimal exponent. What does that mean? I guess, it means the E business, I guess. Alright, let's try that. So from str, I don't know why that didn't auto-complete for me. That was what confused me. And pass in literal. And then we're going to map any errors. Exactly, I'm just copying above. To say, you don't need to wrap it in error anymore. But is it going to automatically add curly brackets, or am I missing? I'm missing curly brackets around this function. I mean, basically, I'm so lost about what I've done wrong here. Let's try and line it up with the one above, see if we do any better. So, oh yeah, I am missing another bracket, which is the end of the map error thing. There you go. Okay, so now it doesn't like from str. Maybe I need to bring it in. Yeah. So I need to import from str. Stud str from str. So use stud str from str. Simple as that? No, right, so it's expecting a result of value, and I've given it an F64, right, so yeah. I forgot the other part that we also did for int, which is that once we've got it, we need to map it into an F64 value. Like so. And I think we're looking pretty rosy. Okay, some things were okay. Okay. Now our test is failing for the correct reason. So we are rosy. So we need to ignore this test. But we're doing really well. Basically, we expected this to be an error because it doesn't type check, but we haven't written any type checking yet. So we've done pretty well here. Let's get diff to figure out what we did. Let's start with the lexer if we can. Oh, the lexer's in the middle. Never mind. All right, let's look at things one by one. So the lexer now looks for 0 to 9, and if it finds it, that means a number is starting, but it doesn't know whether it's an int or a float. So now we call int or float. And what int or float does is pretty much what int did, but if it finds a dot, it starts looking for just a float, which is like the rest of a float. And the rest of a float is basically other 0 to 9s, no more dots allowed, and then return a float. And that's lexing, and then obviously we say there's a thing called a float token, and a couple of tests for oh yeah, this is the function for making a float just in test land, and then we say if we lex a float, you get a float. Simple as you like. What about the parser? Again, pretty straightforward. There is a thing called a float, which is a type of leaf token. In test code, we need a way of constructing one of those things. And if we find a float token, then we return a leaf. This should be called leaf tree kind, or leaf tree or something like that. And also we expanded this out, so next time the compiler will catch it if we add a new type of token. And then we added a test for parsing, which says if you found a floating point number, then I expect a floating point token. Like so. And in the evaluator, similar stuff. If you find a float token, parse it using Rust's standard way of parsing floats from strings. This, by the way, will be more complicated when we don't know what type it is yet, but I guess we'll get to that. And if you're trying to add a float, we're going to get this. Like, we haven't got a test for this yet, but if you're trying to add a float to anything, it's going to fail. Even a float to a float, or an F64 to an F64, which should work, but we don't support it yet. There's a thing called an F64, and that new error that we made, we had an error type for it, and then just one test saying if you try and evaluate a float, you get an F64 value, which has parsed that float into it. So that's all good, but we're still, actually what we're doing is being guided by this guiding test. It's just that now we can actually lex and parse this expression. Problem is, we see it as valid at the moment because we're not doing type checking. So we're not actually understanding this colon I32 and saying, oh, okay, X needs to be one of those. So this is not compatible with it. And that is what we're going to get into. So I think next video we will actually be doing some type checking. And that means I've got to figure out how you do type checking. But it's definitely going to come after the parser, before the evaluator, I'm pretty sure. So I look forward to figuring that out with you. See you next time.